That fluent chat on your screen is not a mind. It is a next word machine, guessing one token after another at enormous scale. Here is what that machine actually is. A large language model is a neural network, almost always a transformer, trained on vast collections of text. Its job is statistical. Predict the next token well enough that fluent language, answers, and code can emerge from that one objective. First, the model chops text into tokens, words, or subword pieces. Each token is then mapped to an embedding, a vector of numbers the network can actually compute with. Language becomes geometry before any prediction happens. In 2017, Vaswani and colleagues replaced recurrence with self-attention. Instead of reading tokens one by one, every token can look at every other token in the window at the same time, so the whole sentence relates in parallel. One attention pass is not enough. Multi-head attention splits the same tokens into several parallel views, so the model can track syntax, coreference, and topic at once instead of collapsing every relationship into a single score. GPT-style models are decoder-only and autoregressive. They look only at tokens already written, pick the next one, then feed that choice back in, sampling again and again until the sentence is built one token at a time. Not every transformer generates left to right. Encoder-only models such as BERT see both sides of a sentence at once, which made them strong at classification and search. Encoder-decoder models such as T5 map a whole input sequence to a new output sequence, translation and summarization as a clean input-to-output path. Before chat, the model is pre-trained with a simple self-supervised job: hide the next token and guess it. Web pages, books, and code become the unlabeled training stream. Each stretch of text is a fill-in-the-blank drill, so the network learns language statistics without a human writing a label for every example. Kaplan and colleagues showed in 2020 that this is not magic. Language model loss falls as a power law as you scale three knobs together: more parameters, more data, and more compute. Bigger, better-fed, harder-trained networks simply get more predictable next tokens. Empirical curves, not a proof of understanding. In 2020, Brown and colleagues trained GPT-3, 175 billion parameters. Scale did more than shrink loss. Give the model a few examples in the prompt: 0 shot, 1 shot, or few shot, and it can attempt a new task in context without a separate fine-tuning run. The weights stay frozen. The examples are the lesson. In 2021, Stanford's Center for Research on Foundation Models named the pattern. A foundation model is trained on broad data, then adapted many ways. An LLM is the language instance of that class, one pre-trained base, then chat, search, code, and summaries built on top. A raw next token model is not a helpful assistant. It completes the pattern in front of it. Ask it to answer a question, and it may keep writing more questions. Ask it to refuse a bad request, and it may still finish the sentence that looks statistically likely. Fluency is not the same as following your intent. Alignment comes later. In 2022, Ouyang and colleagues trained Instruct GPT to follow instructions. First, people wrote demonstration answers and the model was fine-tuned on them. Next, labelers ranked several completions. Those rankings trained a reward model. Then, the policy was optimized against that reward, reinforcement learning from human feedback. A 1.3 billion Instruct GPT was preferred over 175 billion GPT-3 on their prompt set. Smaller, but better aligned. Chat products wrap that aligned model in extra layers. A system prompt sets the role. Safety filters block some outputs. Tools let the model call a calculator, search, or code runner instead of guessing. Retrieval Augmented Generation, or RAG, stuffs retrieved documents into the prompt so answers can rest on current or private sources. Not only on weights memorized at training time, what they do well is pattern work at scale. They write fluent prose, match a style, summarize, and draft. They help with code, translate, and pick up a new task from a few examples in the prompt. Give a decoder-only model, translate to French, cheese, and it assigns high probability to fromage, not because it opened a dictionary, but because that continuation was statistically common in training. Fluency is not understanding. In 2021, Bender and colleagues argued that a language model is a stochastic parrot. It stitches likely forms of language without grounding in the world, without intent, and without anyone accountable inside the weights. It is not a mind. It is not a fact table. Polished sentences can still be unanchored, biased, or overtrusted because they sound like someone who knows. Governments now treat those gaps as infrastructure risk. NIST's generative AI profile names confabulation, fluent text that sounds true but is invented. Its adversarial taxonomy adds prompt injection that hijacks the instruction, data poisoning in the training stream, privacy leakage from memorized text, and harmful bias that travels with the data. Alignment and product wrappers reduce some of this. They do not erase it. Large does not mean a standards cutoff. No committee drew a line at 1 billion parameters. Counts in papers are self-reported and depend on the architecture. Frontier sizes, training mixes, and product names also move faster than the literature. Treat large as comparative, enough scale that next token prediction starts to look like language work, not a certified size class, and not a catalog of this year's chat apps. Foundation models remade NLP. Instead of a separate specialist for every task, the field now leans on a few general models plus adapters, fine-tuning, retrieval, and agents. That concentrates compute, data, and evaluation. Scores also wobble with the prompt and the context. The same model can look strong or weak depending on how you ask. A large language model interpolates patterns in text. Hold the architecture, the alignment, and the limits together. It is a statistical engine with guardrails, not a mind.